dive directly into the presentation. So Stella and Clément is online. Okay, floor is yours. You like, let's, yeah.
Okay, so good morning, everyone. My name is Stella Bourdin. I am a postdoc at Oxford University. And for this project, I teamed up with Clément Devenet, who is a freelance climate service provider. He is attending online, but I would be doing the presentation. For this project, we had a group of excellent mentors. So you just heard from Aaron. We also had Laurent Dubuche from the French transmission system operator. Eddie and Niklas from here at ECMWF, and Stefano Cordido from Inside Climate Services. And our project is called WEAVE for Weather Energy Analysis and Visualization for Extremes. So Arvan already gave a very good introduction, but I'm going to repeat a little bit. Some of you might not realize, but energy systems are very sensitive to the weather. Because on one side, demand depends on the weather, especially on temperature because of heating and cooling. And also production depends on the weather, especially renewable productions, including solar, wind, and hydro. And energy systems are increasingly sensitive to the weather in the context of energy transition, because we are electrifying heating systems, vehicles, so we have a more weather-dependent demand, and we also have an increasing share of renewable energy in the European energy mix. And as you might know, the weather is changing with climate change, in particular the extreme events. So we focus in our project on extreme events. So Arvan also just introduced the challenge, so I'm not going to be too long, but the challenge was to design a visualization tool for the PECD 4.2 database, which includes climate and renewable energy variables for historical and future scenarios. So we have 6 models, 4 scenarios in that database. Climate variables include temperature, winds, precipitation, solar radiation that are relevant for either demand or production. And energy variables include hydro, wind, and solar charge factors. If you're interested, this database is already available on the Climate Data Store. And it was built as a collaboration between C3S and SOE. And this was our proposal as an answer to this challenge. So this was a mock-up that I drew back then, where the point was to design an interactive interface where the user could select countries and variables and get a sort of dashboard with information from the database that would tell them the events that were corresponding to the extreme event they're interested in, their properties, and some geographical information. But now I'm going to present to you what it actually looks like right now. Before I do the demo, I just wanted to introduce the way we define what we call the extreme events. So we are particularly interested in compound events, compound climate and energy events, meaning events where you have an extreme climate condition and an extreme energy condition. For example, the climate condition can be the temperature is very cold. It's important because it means you have high demand from heating. On this, I show, for example, let's assume that over time, when this is purple, we have our climate event. On the other side, you may have a concurrent energy event. In that case, for example, assume solar photovoltaic production is very low because you have clouds and so on. So that could correspond to the orange events on this timeline. And what the TSOs are particularly interested in are the compound events. So times when demand might be very high and production might be very low. So these are compound events are when both conditions are true at the same time. So that gives you a time series of compound events like this. And now I'm going to try and do a live demo. Let's hope for the best. So,
Stop sharing here. Sure. This is yours. Okay.
yes.
All right. Is the movies school?
Maybe in the meantime, I just on my side it's
Yeah.
maybe in the meantime I can just explain a little bit. So we developed two different notebooks. One we call the E notebook, and it's actually a clickable interface. And the other one we call the expert notebook, which is where you actually access the code. So if you want to tweak some things, it might be easier, but you need to do a little bit of code. Whereas the E notebook does not require you to do any kind of reading.
Yeah, we have to do
That with this.
You to do.
So I'm going to start with the easy notebook. So as you can see, there is actually quite a lot of code, but the point is you hide it. And now you have access to an interface that allows you to choose to define the event that you're interested in and a number of parameters. So for the sake of this example, let's say I want to look at 2-meter temperature and wind power onshore capacity factor. I can choose the technology, but I won't go into details. You have different technology scenarios in the database as well. And because we're in Bonn, let's say I want to look at German. You can select the period that you're interested in. So for example, I can say I'm interested in the last 50 years of the last century, and I want to have a look at the end of the century for the projections. And some of the plots will have a rolling mean, so I might take, say, 30 years. Now I define my events. So my climate event is with respect to temperature. So I can say, okay, I want to look at events where the temperature was below 5 degrees. And I want to look at events where the wind capacity factor was, let's say, under 10%. You can select and deselect some of the models. If you really don't like one of them, you can remove it. If you like both of them, you can keep them all. And then you click on execute, and you've got this running thing here, and it's done. So what is done actually? You have these plots that we'll show. So we designed the plots exchanging with the mentors to find what would be more important for them to have as information. So the first plot you have shows the number of events. So for all of these, we separate between the climate events, the energy event, and the compound events I defined earlier. And you can see for the historical and the different scenarios, the number of such events. In that case, we see that the number of events in terms of temperature does not change too much, but the number of energy events might increase with climate change, whereas the number of compound events might also increase a little bit. Now, if you want to look at the full time series to get an idea of how this evolves with time, we have the time series, so showing the historical as well as the scenario. The thick line shows the multimodal mean for each scenario, and you have the faint line that show all of the models. And what's also quite nice is that because we use the Plotly library, you can hover over the plots and see the actual values. And you can also, for example, click on the legend to hide one scenario or to see it on its own. You can also zoom on a particular part of the plot, for example. So that's really nice, and that's not, I mean, that's Plotly, which is really good. And we also have plots showing the duration of the events, because the TSOs might be interested in if in the future the events where it's very cold are shorter, then it's important for them to know, because they can maybe deal with a 2 days cold wave, but have much more difficulty dealing with a 1 week cold wave. So in that case, for example, you can see that the mean duration of historical events is about 10 days, but the mean duration of future events is much shorter, around 5 days. And the last one we have here shows the seasonality of these events. So as you can expect, cold waves are in the winter, while periods with low wind capacity factor are more in the summer, when you don't have storms going in. Maybe I should just have specified that capacity factor means how much energy your turbine is producing compared to what it was designed to produce at the maximum. So it does not depend on how many turbines you have. It depends on how effective they are at a given moment compared to their total capacity. And you have a seasonality for the compound events. So all of these are with Plotly, so you can zoom on this one as well, etc. You can deselect. And to give you a quick overview of the expert notebook, it does actually the exact same thing. Part of this code is in the other one. But the point is, if now you're not exactly happy with what the notebook allows you to do, if you want to do something a bit more fancy, and you feel like you can do a little bit of code, that you can use this notebook and change, for example, there is a variable in there, or the country. You might want to do 2 countries instead of just one, so you can do that. And it gives you the exact same plots. Sorry. Okay. So that's it for my demo.
Let me just go back to that.
Yeah, sorry.
Okay.
I was not quick to the end yet, but
Where
yeah, that's good night.
yeah,
It was or was it this one? Okay, thank you. So this was an example I prepared in case the demo did not work, but it did work, so great. So now I just want to tell you a little bit about what's behind this interface. So in terms of data, we had to make choices because the database is actually quite heavy. So we made the choice with the mentors to only work on NUTS0 data. NUTS0 means country aggregated, which is why I showed you we selected a specific country. But the data is hourly. The full archive with just that is already 300 gigabytes, which is not much if you use to climate data, but is a lot for TSOs. And what we also did is, for the purpose of demonstrating and also to share the tool more easily, we pre-processed daily means for all the variables, and that archives is only 500 megabytes, which is much easier to send to people as long as you only want daily means. And this data is on the GitHub repo. So with this data, people can just download the repo and run everything. One of the future development that we were not able to do during the challenge, but that would be very good, would be to directly link the interface to the climate data store. So send requests to the climate data store to be retrieved on the fly, so that you could do everything, whether the aggregation or the frequency you need. And a little bit about the backbone of our interface. So we developed say backend package we call WIFP that has all the functions that on which the notebooks rely. And just as a side note, we have dependencies on NumPy, Xarray, and Pandas that you probably already know about. We also use Seaborn and Plotly, more importantly, for the visualization, and obviously Jupyter, as well as IPWidget for the interface, where you can click on everything. And last word on the future developments, what could this tool become with a little bit more work? So it currently works on the ECMWF notebook interface, which is a new tool that I don't know if you all know, but ECMWF has Jupyter Hub now that I think everyone more or less can access. So it's on there, so if you want to try it, provided with the right path, which is not maybe obvious, but you can use it there. And that's where we would like to link it with a CDS. And the easy version we would like to make available on Clément's website as well. Long term, it would be good to optimize part of the data reading because it's, for what I showed, it was a preprocessed archive. If you want to do something more fancy, then you need to reprocess the data, and that takes a few minutes. So that's not so nice. We could provide more plots depending on what the TSOs need. And of course, if new versions of the PCD come out, then it would be nice to be able to follow that. And that's it for my presentation. Thank you very much.
Thank you very much, Stella. Are there any questions? Yeah.
Can you say a bit more about the difference between the expert and the simple tool? Because, you know, what you said, the simple tool already seemed to be able to do a lot of the things that you might want to do. And the expert tool, the only difference that I noted that you did talk about was that you were able to combine several countries.
Yes, so for the easy one, we made a few assumptions about what the user would want. So once you have a country, you can only combine a climate and an energy variable. But with the expert notebook, you can extend it. So if you want instead to conquer 2 climate variables, you can do it. If you want to see more countries, you can combine them. If you want to see 3 variables, combine 3 variables instead of 2, you can do that. So it's more about being able to extend what's already in there by seeing the code that's actually behind it. Yeah, does that answer your question?
There was another question, and then, oh, okay, Niels, please.
That's very nice. I think one suggestion could be the future also thing we are making in destination Earth data, which are dividedly to create as the proposal and other parameters that people in the energy sector, and are they interesting to see how it gets data source. I don't know if it is to change if you have the best to project. But like that, but if you take the durable projection are very high, which are close cross just textual that so sizes available, but they could be intriguing.
Yeah, I had no idea that Destination Earth had energy data, but I would say that the front interface could be kept. Part of the back end is really tied to the way the VCD database is built, but why not if you convince Ansori to use that, then maybe they can have another challenge later on.
Oh, das sind die Autotraktor. Okay, any more questions? No, then another round of applause, please. Hmm.